Alright, so now we are ready for our 1/2" parts. We have mounted our 1/2" plate in the machine, and we're going to set up to cut the 2 end blocks that the bearings are going to go into. Okay, we have our part mounted, and we found 0 back down to the base here. It says this is a little bit thicker than 500 thou. It's about 535 or so. So we've set that up. We changed our program to know that that's the thickness. We're again zeroing the Z off the bottom so we can leave a little bit of an onion skin. We've got our X and Y zeroed. We've got our G code loaded for the through holes. We're ready to go. So let's cut those through holes. Now fully through on all of our holes, and we know we did well because when it went through there was marker on this board, this marker right here, and it didn't cut it all away, so we found exactly where to put that depth. And it seems, one, speeding up the feed rate, change nothing else, just speed up the feed rate, improved my surface finish considerably. I also think, I saw it, I was watching it cut the bigger holes, and the second pass was taking some off the sidewalls, which makes me think that in the full cut, while it's slotting basically, the cutter is deflecting a little bit, which is probably really affecting my surface finish too. So the second pass was taking a little bit off as well, so things were a bit undersized before. So we're pleased with the through holes. We're going to do the bearing sockets next, and hopefully I've got those sized just right for another press fit. We got lucky on the last one. We got it in 1 in the first pass, so we're going to try, hopefully be that lucky again this time. So we'll be back to you when we're ready to cut the bearing sockets. The bearing sockets have been cut. Let's see how tight a fit we are here. That is about as good as the other one was, the first one. Yeah, that'll push right in there nicely. Okay. It's not the greatest surface finish, though. I noticed one of the things that was a little weird. This was a pocket cut that kept stopping here. So it would go around and it would ramp a bit, and then it would come all the way around, stop here, and come back and go back. So it just kept pausing here. And there's a little bit of a ridge there. The rest of it is reasonably good. it could be better, but it's fine. It'll serve just fine. I had to slow it back down. I think cutting it about 50, I think it was 50 inches per minute, was a bit too much for this full-on slotting going on here, which was interesting because the other ones did fine. I think it had to do with the way it did the ramping or something. And then the other thing I wanted to mention, so I cut it down to, for this one I knocked it down to 39 inches per minute, or about 40 inches per minute. I have been cutting, all of my G-code got generated to cut at 30 inches per minute. So all of yesterday's cuts, all of the part 5's cuts were 30 inches per minute, and I was having a little bit of gumminess going on. When I did the through holes, I did it at 55 or 52 inches per minute, and it did better. So, and I got a smoother surface. So I'm going to kind of experiment a bit more and see how the profile cuts, because that's the only thing left now is the profile cuts. And we're going to see how well it cuts these parts out. Again, I'm leaving about 10 or 15 thou onion skin on the profiles so that they don't poke all the way through and free themselves. So we're going to get set for profile cuts next, and we'll bring you back. Okay, we're set up to do the profile cuts now, and that'll just cut these out, leaving about a 10 thou onion skin that I'll cut out on the bandsaw. We're going to try this at the through hole cutout speed, but I'll be ready to knock it back if I have to. So we'll get that going now. Alright, the profile cuts are done, and I tried couple of new things here. First, let me clear this out and take a look. So, one of the things I tried at first was I tried to get back to so the first bit, it seemed like 60 inch or 51 inches per minute was too much, so I slowed it back down. But then I had a thought that maybe turning the RPMs down would help. So when it got to this part was cut with it started out at the high RPMs, and I lowered the RPM after, like the first or second pass. So this part got cut with a slower bit speed, turning speed, cutting speed, and I bumped it up to 45 inches per minute. So it was taking a much bigger chip, and I think that's a good thing. What I'm finding is that, well, one, the bigger chip's going to carry away more heat, and from what little I can tell, the finish is a little better too. So we're going to take these out of the rig, and we're going to get a look at them. So we'll take a look at that in a minute. All right, we're going to free the big part off the table here, and see if I can get a look at the surface finish left by the slower RPM spindle. So let's, boy, this stuff gets everywhere, doesn't it? It's all over. Try not to get any in my eyes, that would be good. So We didn't get the discoloration on the back. That doesn't say much. It might mean that I just didn't go very deep or not anything, but near as I can see, it definitely looks like it's better. So we're gonna do the next step we're gonna do is we're gonna go over to the bandsaw and we're gonna cut these pieces out completely and see what they look like from there. Okay, so now we're gonna just cut these parts out and get a sense of what they came out at. This was the one I cut first, and you'll be able to see here pretty easily. That's my surface finish. Can you see it very well? Probably not. There we go. Let's see how rough that is. There you go. There's a good catch of it right there. So there's that one. And here's the part I cut the second time. So this was part first. This is the second one. It's cleaner. Smoother. It's not perfect, but it's way better. So progress has been made. So let's cut the rest of these out and then we'll file those edges nice. We freed all of our parts, and definitely not a good enough surface for a customer on these cut edges. But I can say that I have made progress. There is improvement, and just between these two parts, it's pretty obvious which ones I cut first and which ones I cut second, because it's tinier chatter, so lower RPM and faster feed rate seems to be some of the trick there. Obviously this is all probably known information to most metalworkers, but I'm a pretty amateur guy, so I'm learning, and hopefully I'm learning the right things. So now all we're going to do is, we've cut them all off on the bandsaw, and that little web we left, that little onion skin we left, is just all that's left behind. So we'll file them down to get rid of all of that. This is too slow. Okay, we're gonna go after this with the belt sander instead. so then there's these inner sections that I need to get smooth and clean and whatnot. Got the outers pretty good for everything, but I can't get in there with a sander, so I have to do that with the file. We'll do that now. Alright, so we have now deburred all of our parts. We're still missing one piece, but it's not a huge thing. So what we've got is our bearing, our pinion bearing plate. That takes this little bearing, this little gear, and then this bearing will be pressed on there and pressed into there. And then it'll hang down here. And then on top of those, we'll have these plates. Sorry, we'll have these plates that'll sit like this. Let's make sure we get our diameters the same here. They are just slightly off center one another. If you put them together the wrong way, you'll miss 1/4 of an inch, so we don't want that. So I think, if memory serves, the short side is the side the gear sits on, or the short side is the top. So this will go like that. And of course our spindle will be in there. In fact, let's give you that view here real quick. Well, I'll show you the enclosure first, and then we'll get to the view of the whole thing. So the spindle will go through. These will sit here. These little guys are just little catches, so, and they're almost perfect squares, but not quite. So I have to get them flipped the right direction. So we have these guys, and those will bolt into those, just like that. This will go here, and so we've got these holes here and this hole here. What I wanted to be able to do is tilt the spindle in this direction. So these 2 set screws here will get drilled and tapped. These holes here will get drilled and tapped for set screws. They'll be the tilt. These 4 holes are the locking. It'll hold it down. And they're slotted. You can also adjust this direction. The part we don't have done yet is over here will be a part. And we are just about as designed. 1/16 undersized over here, which is just about right. So that'll let that go that way. And these little guys are what hold it to the router table, or to the spindle of the CNC. They go like so. And I'm not sure if they'll sit, but you kind of get the idea here. And they sing up, so we'll turn this way and you'll be able to, we'll do an ISO view here. How's that? This one will go here like so, and this one will go here like so. And that'll hold it to the router table, or to the CNC, to the Z-axis spindle. And that is that. Let's get ready to show you what the spindle will do inside of this. Alright, so now we've got our spindle parts. Let's call that the front, okay? So this will be in here like this or so, with these guys in between them. Just like this here. Let me turn it that way so you can see us. So that's where the spindle will sit. Of course it'll be on the bearings, but this gear will go in there like so. Still have to do some drilling and tapping, but I'm saving that for a bit later. So now you'll see this way. Yep, this looks about right. So that'll be there. Obviously this plate will go here, but I'm leaving it open so you can see it. So then this bearing will be pressed on, as will this bearing be pressed on this end. So this will go in like this. So like this will be pressed into that area and onto this bearing journal here. But the idea is that there is not a ton of space here, just a little bit. So I'm just going to have just enough so this bearing will be just pressed inside of there into this, and then all the other stuff will be on there. But basically you kind of get the idea if I just show it to you in this form. Like so. This on here, and this on here. And then the other piece is this part goes on like so. And we'll get that gear about in the right place here. And we'll put that on here, and then the gear, this gear has to go in like so. We'll be in here and spin the big gear down there. So clearly a few pieces to go yet, but we now are mostly parts ready. The only piece missing is when we've got this part on here like so. These slotted holes go in here to hold it down, but I'm going to have a piece hang off the backside, a little piece of 1/4 inch square that will let me push set screws against it so I can turn this whole assembly on the axis of the router so that it can align with that axis. That will become clear after a bit. Okay, so we had one more part that we want to make before we do all the drilling and tapping. So the way the system works is there'll be 2 set screws that allow, they're not really set screws, they're more like adjustment screws. And let's just imagine the spindle is going to be in there like this. I want to be able to adjust for tilt or pitch, I guess. And I also need to be able to adjust this way because I need to make sure that the blade as it sits on there is perfectly vertical and perfectly parallel with the axis that it's going to travel on to cut the slots. So I need to tram that in. So what I have built in is these 2 holes will be drilled and tapped for set screws, and that will cover the tilting. That'll give me the pitch, the leaning, tipping down or pointing upward. The other holes in here are slots to allow, these holes will actually be the mounting holes that hold things down, but they're slotted so that I can then have the spindle twist a bit, and that will get me this direction of planarity. So it should give me tilt and pitch, or I guess pitch and yaw. I think this is. I think if you do this, this is yaw, and this is pitch. So that's what we need to work out next. And in order to do that, I don't want to just have it loosen the bolts and yank it and hope that when you tighten things down, everything stays put. What I want to do is have a small piece of, I've designed it to have a small plate of 1/4 inch sit down and behind it. It'll actually be on the back side with a pair of set screws pushing against these walls to tilt one way or the other. So you basically loosen one and tighten the other to get it to turn one direction. Okay, so we have our 1/4 inch stock in. We've zeroed it like we did before. This time it's just one path, one tool path. I'm going to do both the through holes, which is just 4 holes, and then a cutout, which is just rectangular. So we're going to start cutting that right now. It goes to show, on the last part, that's when you break a bit. What happened is almost certainly I slowed the router too far down. I was playing with the feed, the RPM of the spindle, and sure enough, that's when it snaps. When you're on your last cut, that's when it'll go. So we'll switch the bit out and restart this program. Thankfully I wasn't too far into it. Yeah. Well, I'll give this bit some credit. It made it a long way. You can see it's got some goo on it. It's kind of gummed up with aluminum. So we'll change out the bit and start over. That was a quick little tool path, nothing to it, just a couple of small cuts. I did keep the router speed slower because I seem to have had pretty good success with that the last time. So we'll pull this off and have a look at it and see how the cut quality turned out to be after all. Alright, well, that came out actually really decent. It's probably my best finish so far. So I probably slowed the router down just a little bit more. The RPM was low. But I left the feed rate at 30, and you'll see the shiny part on the bottom is where I sanded, but the part on the top was the cutting spot. Don't know how tough that is to see, but anywho, this one's pretty decent. So now we're ready for the drilling and the tapping.